Then loads cause deflections, static deflections. They want to be small enough. They cause vibrations. They don't want to be in the same range of bells and humans and machinery, so that there's a resonance catastrophe, as we say. And also they cause reaction forces. There's like a force flow that we need to examine. Here you see the normal compressive forces. Each color has a different degree of force in that particular member. And by the way, the green here is the reaction. It's the biggest load, as we saw earlier, is going in this section. And then from the normal forces we have the moments and the shear forces. Do you see here this typical QL squared over 8 pattern? That's coming from the continuous roof snow load in this case. And then you also have shear forces, and what shear is and so forth we'll learn in a separate lesson. This is the pattern for shear. And those three combined give you stresses. They give you the ultimate limit state for snow in this case. And now you understand why you need to understand the systems, the force flow, because you want to convert the snow loading into forces, normal forces, moments, and shear forces all over every piece. It's expressed in these diagrams. And from these diagrams you can then determine, is my member, my material overstressed or not. Stability is not caught with this. Stability, as we just saw earlier here, is a sway to the side, is a buckling out due to slender members that have a tall span and have a relatively small cross-section. Or let's look at live load. By the way, what's the difference between live load and super dead load? Well, live load are loads that don't have to be permanently placed on all the slabs. Maybe you just have an event here or a very heavy showroom with heavy furniture, so the live load is not happening in all these other floors. So I may have to account the live load being in every bay separately, and I've just chosen here live load on the staircase and live load on the second floor on one bay. And again, the deflection then is different. It corresponds to where that load is actually placed. And now you see also the reaction forces are different, because as you can imagine, the force flow comes down here through the column, not so much here because there is no live load, and then the reaction forces, the compressive support forces, they balance out what the load was doing in coming down from the stair and from that particular floor. And of course, the bending moment now looks different than it used to be. This pattern here is not in all the bays anymore. See, on the snow load it was where the load was on the roof, but it's corresponding to this particular load case. And so the same with the shear forces here. This is the pattern for the shear force on a line load. And again, we would check what from all these moments and forces is my maximum stress or shear force, and make sure that this is smaller than the 100% capacity of the members, and that is called the ultimate limit state check. That's it for the first lecture, and I hope to see you all next week. Thanks a lot.